right. Polynomial long division. Now, long division is when we take two polynomials and we divide them. It is a repetitive process that seems complicated, but is really not complicated if you simply learn the few rules necessary. All right, so here we have the polynomial 4x cubed plus 4x squared minus 8 divided by 2x plus 1. And I want to adjust this a little bit. I want to change it to 4x squared plus 4x minus 8 rather than the cubed and the squared. All right, so now we have 4x squared plus 4x minus 8 divided by 2x plus 1. I did it the other way for the previous class, and it came out fine. There's nothing wrong with it. I just would rather do this one, okay? All right, so what we're going to do, anytime we're doing polynomial long division, listen, is we're going to look at the first terms of the two polynomials. The polynomial inside is called the dividend. The polynomial on the outside is called the divisor. So we're going to look at the first term of the dividend and the first term of the divisor. We're going to divide those. So it will always be 4x squared over 2x. You're always going to take the first term on the inside and divide it by the first term on the outside. So 4x squared divided by 2x. Now, what is that? 2x, because 4 divided by 2 is 2, x squared divided by x is x. Now, you put that result on top of the second term, always. Always on top of the second term of the dividend. All right, now we take the 2x and we multiply by the divisor. So 2x times 2x plus 1 gives us 4x plus, it's 4x squared rather, plus 2x. All right, now, if you remember back to elementary school, when you're dividing, I'm always subtracting, right? So I need to change these signs to the opposite of what they are. When I divide, after I've determined what goes in the quotient, then I multiply that quotient times the divisor and then subtract that number. So that's why I'm subtracting. All right, so what happens? These go away. 2x gets brought down. And then bring down your minus 8. It's not squared. I'm glad you said that. Because when you're combining like terms through addition subtraction, you just keep the exponents the same. All right, so 2x minus 8. Now I'm going to look at the first terms once again. The process starts over. It repeats itself. 2x divided by 2x is? 1. Remember, 2x divided by 2x, everything cancels. So it's just plus 1. Once I've got my plus 1 up there, now I'll multiply the 1 times the 2x plus 1. And that gives me 2x plus 1. But I've got to change my signs because I'm doing the opposite. I'm subtracting. So change these to minus and minus. So 2x minus 2x is 0. Negative 8 plus negative 1 is negative 9. So negative 9 is my remainder, part of my remainder, I should say.
Negative 9 over 2x.
Exactly. So you're going to take your negative 9, which is part of the remainder, and put it over the divisor. So it'll be minus 9 over 2x plus 1. So my final answer, final answer is 2x plus 1 minus 9 over 2x plus 1. And the reason you put it over 2x plus 1 is the same reason we did it when we did division when you were in elementary school. If I had 10 divided by 3, and then I ended up with a remainder 1, it's not just 3 and 1, 3 remainder 1, it's 3 and 1/3. So the 3 plus the 1/3 gives me my final answer. Same thing here. Whatever I end up with on top, plus or minus, whatever the result was over the divisor. Okay, so that's long division. Let's do another long division problem. Okay, got to erase this one. Alright, let's just do this. Alright. You can see the answer there, but let's see how we get to it. Alright, so we got 3x squared plus 1x minus 2 divided by x plus 1. So in this problem, first step is to look at the first terms. 3x squared divided by x. And what does that give us? 3x. So the 3x will go in the numerator. Alright, once I get my that part of the quotient, I multiply that by x plus 1, and that'll give me 3x squared plus 3x. But I got to remember to subtract, change the signs. Minus, minus. This is going to give me 1 minus 3x, which is negative 2x. Okay, bring down your minus 2. So now I take the whole process and repeat it. Negative 2x divided by x is what? Negative 2x divided by x, negative 2. So minus 2. Negative 2x divided by x. The x's to cancel. That leaves negative 2. Okay. Now, once I get that negative 2 up there in the divisor, the quotient, now I'm going to multiply the negative 2 by x plus 1. That gives me negative 2x minus 2 with the big but. Alright? Got to change your signs. So this becomes positive and positive. Those cancel. These cancel. 0, 0. So what's my final answer? 3x minus 2. Okay? So that long division problem did not have a remainder. They won't always have a remainder. However, the remainder is important. Okay? Because most problems will have them. In real life, you're going to have some leftovers. Alright? That's what a remainder is, just leftovers. Alright? So real life, you almost always have leftovers. In math, sometimes we manipulate it so that we do problems that don't have leftovers. That's really not realistic. Okay? So a lot of the problems that we do will have leftovers. Now, before we go on to synthetic division, alright, which is just a continuation of long division. Some people say it's a whole lot easier. It's pretty easy. I want to talk about some of the theorems that are in your book. So go ahead and get your book out if you've got it with you. Open, and you can look on with somebody close to you. Alright? We're not going to be doing any problems from the book. We're just looking at an example, and I'm going to show you. Alright, we're going to turn to page 480. Alright, page 485. Okay. Okay, we're going to start out by looking at something called the remainder theorem. Alright. The remainder theorem is going to be used when we start talking about synthetic division, and then when we go from synthetic division to later on to using the polynomial and the remainder, alright, or aspects of the polynomial, and the divisor in order to find out facts about a certain function. All right? So this remainder theorem is going to be very important for us in the future. All right, let's see what it says. All right. It says, if a and you're going to write down some of this, but not all of it. So this is what I want you to write down. If a polynomial f of x is divided by x minus a, all right, so f of x divided by x minus a, and I'm going to say the word if here. If f of x, which is a polynomial, is divided by expression x minus a, the remainder is the constant f of a. Let's just stop there. Okay. Now, let's get our understanding of remainder squared away here. All right, don't write down what I'm about to write. If I do 10 divided by 3, we did this a minute ago, I end up with remainder 1, right? You remember when you did this a long time ago, you just had to write what the remainder was? They didn't always ask you to write out the final answer, 3 1/3, all right? That's what we've been doing when we do long division, right? We get that remainder and then we add it into, we include the divisor to make it the actual answer, right? But when it asks for the remainder, a lot of times it's just referring to whatever you end up with down here. Okay? So just understand that. So what this is saying is, if I take this polynomial divided by x minus a, and you've seen when we divide long division, it's like a lot of times we use like, it could be x plus 3, it could be x minus 7, it could be, you know what I'm saying, 2x plus 2. All right, so we're dividing by some binomial generally. The remainder is the constant f of a. Now, what is f of a? That means a function of a, right? That means I take the a value and plug it back into the function. Right? Whatever is inside parentheses is what's being plugged into that function for x. So where does this a come from? It comes from x minus a, right? So what does a do to x minus a? If I plug in a for x, what does it do? A minus a is 0. It makes 0. So in other words, if I take whatever number makes this denominator 0, the divisor, whatever makes that divisor 0, if I take that number and plug it into my function, I'm going to end up with the remainder. That is very useful information because that keeps me from having to do any work, well, a little bit of calculations. If somebody says find the remainder, I'll give you an example. All right? Don't write this down. Somebody says find the remainder when 3x to the 9th plus 2x to the 8th minus 7x squared plus 1 is divided by x plus 2. All right, now do I have to go through the whole long division process to find out what that remainder is? Negative. All I got to do is take the opposite of 2, which is negative 2, plug it in, and that gives me the remainder. So we can do that. Well, that's going to be ugly. Never mind. Let's don't do that. But that will give us the remainder. In other words, f of negative 2 would be our remainder. Whatever I get when I plug negative 2 into this function, that's going to be my remainder. Did I have to do long division to do that?
No.
Or synthetic division? No. There will be problems that just simply say find the remainder. All right? You don't have to do all the work. You just take whatever the opposite of that divisor is, whatever makes that divisor equal to 0, plug it in, and you have found the remainder. Okay? That's the importance of the remainder theorem. Now, this isn't all of the remainder theorem. There's a little bit more to it. I'm not going to have us write it down, but I am going to have you look at it. If you look at it in the book, basically what we have here is the dividend. This is the dividend, the number that you're dividing, that gets divided into. All right? The dividend is equal to the quotient times the divisor plus whatever the remainder is. Now, in math terms, that means f of x equals q of x times x minus a plus f of a, where q of x is a polynomial with the degree 1 less than the degree of f of x. So when I come out with my answer, my quotient, q for quotient, all right, that quotient is going to be 1 degree less than my original dividend, right? Because x is 1 degree less than x squared. All right, so that's not really, I mean, we're not really, we don't need to write that down. That's just the result. That's what happens. But the main thing I want you to remember is this. If I take a function divided by x minus a, the remainder is going to be the constant that I get when I plug a back into the function. All right? That's a very useful, helpful thing to know. Now, because of that, because of this, we can do what's called synthetic division. All right? Synthetic division is a shorthand way to do long division. All right? But it will immediately give us, the remainder. It takes us to the remainder. All right. Now, this is not right. Let me delete that. All right, so write this down. Copy this down. That's a 3x to the 4th, and my pen is doing crazy stuff. Let me just fix that a little bit. All right. Copy this down. Sounded like Javon walked down the hallway. Whistling. My mom always said, stop whistling. She always made me stop whistling. Did y'all ever know, I don't know if y'all knew this, but mamas have doggy ears and eyes in the back of their head. Y'all know that? Every mother has doggy ears and eyes in the back of their head. I promise you that.
They have eyes in the back of their head. Come on, deaf.
She may be deaf when you talking to her face to face, but I promise you she got some frequency that you don't even know about. Yeah. Fathers, on the other hand, daddies, their hearing is not quite as good. Or put it this, maybe their listening skills are not nearly as good. All right. Okay, so what we're going to do, instead of doing this whole long process, we're going to write down the coefficients of each of the terms. Now, notice our exponents. 4th, 3rd, 1st. We're missing the 2nd. Any term that is missing, you plug in a 0 for the coefficient.
That's what it is.
All right, that's where the 0 comes from. So, 3, -1, 0, because we're missing x squared. 2, -6. All right. Now, the reason we have we can bring down the -6 is because it goes with x to the 0. And what is x to the 0? 1. So 1 times -6 is -6. All right. So out here in front of these coefficients, in the little box, we have a 2. Where do you think that 2 came from? X minus 2. It is the opposite of -2. It is the value that if you plugged it in to this divisor, you would get 0. This is your A value from the remainder theorem. That's your A. So if we took this A and plugged it in right here, we would get the remainder automatically. Or we can go through the process of synthetic division to get the remainder. They're going to ask you at some point, I'm going to ask you to do it different ways. At first, on our quiz tomorrow, on synthetic division, tomorrow's quiz, all right? Tomorrow's quiz on addition, subtraction, multiplication, and synthetic division, long division, synthetic division. The quiz tomorrow. Okay? Not last week's, but tomorrow's quiz. On tomorrow's quiz. All right. What I'm saying is, y'all better keep up. We're gonna have lots of quizzes and tests. All right. We have a test Friday. I'm not joking. We have a major unit test on Friday over everything we've studied. All right. All we're going to do is basically quiz and test. That's constant. All right. So, with that said, this 2 is going to be multiplied by the first coefficient. Now, you're going to draw a line, leave a little space. You're going to multiply the 2 by the 3 that you brought down. You always bring down the first coefficient. 2 times 3 is what? 6. That 6 goes underneath the next coefficient. All right? And then you just add -1 plus 6.
5.
It's just 5. All right? Then you multiply 2 times 5. 10. Put the 10 here underneath the next coefficient. And then you add 0 plus 10. 10. Okay? Then you do 2 times 10.
20.
20. And then you add
22.
22. And then you do 2 times 22. 44. And then you add -6 plus 44. 38. Okay?
How did I know that?
Oh no, you just have a great mind. Alright. Now, once you get to that last number, put a little box around it. Because that is your remainder. If you did the math right.
Oh, come on.
That's the remainder. Now, some problems will just ask you to give the remainder. This time, I'm not just asking you to give the remainder. I'm asking you to write out the full polynomial answer. The polynomial answer is always going to be 1 degree less than the dividend. The dividend was the original polynomial that you're dividing. Okay? So, what was the degree of this one? 4. So what's the degree of the answer going to be? 3rd. So 3. These are the coefficients. So your final answer looks like this: 3x cubed plus 5x squared plus 10x plus 22 plus 38 over what? X minus 2. Very good. Okay?
That's a lot.
Super easy.
This one,
Yeah.
this one is easier.
Actually, I think tomorrow's quiz I had synthetic division as a bonus. Or actually, I may let you do it either way. We'll see. Just the addition, subtraction, multiplication, division. On the quiz from the other day, I did not have addition, subtraction on there, if you remember. All right. So it's going to have addition, subtraction, multiplication, division of polynomials. That's it. So when you add and subtract polynomials, we reviewed it, but we didn't have it on the quiz. When you add and subtract polynomials, do you change the exponents? No, you just look for like terms, right? Okay. When you multiply polynomials, do you change the exponents? Yes, based on if they have the same degree, same base, you add the exponents. All right, so that's all the quiz is over, along with the the long division, short division. All right. Okay, here's another one. All right, now this actually comes from a worksheet, so don't write this down. Yes, but we're going to do a few of them first. Tomorrow's quiz will be the easiest quiz you've ever done.
We got two problems.
The first one, well, this one's going to be easier than that. Alright, we're almost done. Okay. What we've got here is a worksheet. The left side of this worksheet we're going to do by long division. The right side we're going to do by synthetic division. Okay? We're not going to do every problem because a couple of them we're going to do together, a couple of them we're going to skip. I'll show you which ones you're going to do in just a minute. Alright, so here we've got m squared minus 7m minus 11 divided by m minus 8. So what we're going to do is do this. This is number one. We're going to do this by long division. Alright, so we're going to look at m squared and m and divide those. So what do you get? M. So m goes on top of the second term. And then you multiply. M times m minus 8 is m squared minus 8m. But what do I do with my signs? Change them. So that's going to give me negative 7m plus 8m, which is just m. And bring down your negative 11. Alright. Next step, divide the m and the m. What do you get when you divide m by m? 1. So plus 1. And then multiply the 1 times the m minus 8. So that gives you m minus 8. What do I do with my signs? Change them. So negative 11 plus 8 is negative 3. Exactly. So you take your negative 3 and you put it over m minus 8. Minus 3 over m minus 8. Now which m would work? Okay? So there you go. Yay. So our remainder was negative 3, but when we write it as the final answer, we have to put it underneath the over the top of the divisor. Alright, let's look at number 2. We're going to do number 2 by synthetic division. Okay, so in number 2, we have, what goes in our little box for number 2?
Positive 6.
Positive 6. The opposite. Because the opposite is what makes it equal to 0, and that's what we want. Alright, so then we're going to have coefficients of 1, negative 1, and negative 29. Draw your line. What do we do with that first coefficient?
Bring it down.
Bring it down. Some people like to draw a little arrow to remind them to bring it down. You don't have to do that. All right, so 6 times 1 is 6. Negative 1 plus 6 is 5. Now 5 times 6 is 30. Negative 29 plus 30 is 1. That's your remainder. So then I write my answer 1 degree less than the dividend. So my dividend had squared.
So
It's going to be x plus 5. X plus 5. Good grief.
1 over x.
Plus 1 over
X minus.
x minus 6. Very good.
Could it be in?
That's it.
Have to be in.
Was it n to start with?
Yeah.
Yes, it should be n. Either way is fine. I wouldn't count off, but
You also wouldn't give us a point though.
exactly. Good try there. All right, so there you go. Now, this is the one. These are the ones you're going to do for the homework. On the left side, 3, 7, and 9. Number 3 is your ticket out the door. On the right side, you're going to do synthetic division, 4, 8, and 10. And number 10 is your ticket out the door. So I need to see 3 and 10 before you leave.
Or 10 synthetic division.
Yep,
No, can I go to the restroom?
you may.